Dear friends, today I will take you through a small tour of my house and we will study certain situations in our own domestic lives. Please watch what I'm doing. Please see here, one is subjected to the atmospheric pressure, the other one is a pressure flow. Also see here, creating the turbulent flow. Also see here, so you could watch all these situations in our own home setting. And today I would like to talk about certain aspects of the model analysis. So what is a model and what is a prototype? So we all know that we have to construct a lot of dams and spillways, etc., and also some lifeline structures. And aeronautical engineers would like to make a jet, or like a marine engineer would like to make a submarine, and all these things are true, but they are all subjected to a great risk, the financial risk and also the stability risk, and also it may be not possible to conduct experiments on the real machine or the real structure. So this is going to be a great problem, and therefore we have to encounter a very difficult situation, and to overcome this kind of a situation we have to go for what is called a model analysis. And before we understand what a model analysis is, we have to understand one aspect that is called the dimensions of the derived unit of a physical quantity. So any quantity, correct, of course you understand as length, mass and time are called the fundamental units, and the fundamental units are not just the units that we are going to be interested, but we are interested in the derived units of the physical quantities. And what is the dimensions of the derived units of these physical quantities? So the dimensions of the derived unit of a physical quantity is the powers to which the fundamental units of length, mass and time are to be risen in order to represent the given physical quantity. All of us know about this. So having known about this, what a dimension is, that I would like to give you certain hint to what kind of a model law I can use for different situations. First I will discuss the situation number one, which is a small submarine hull is moving under the seabed in Visakhapatnam. And I would like to replicate this model, actual model in AMC Engineering College Hydraulic Lab. How do I do that? So this is a challenge. So what kind of a force that I have to be interested in? So here in this particular kind of a situation, the viscous forces are predominant, and therefore we will have to adopt what is called the Reynolds number, rho VdL by mu, which is going to be more representative for this situation. And what is Reynolds number? It is nothing but the ratio of the inertia force to the viscous force. And in certain cases like the spillway constructions and dams, etc., what happens is the stability of the structure itself becomes very important. And when we are studying the stability of the structure and the failure of these structures, we cannot destroy the prototype itself. So we have to construct small miniature models of this using a certain law, and that is using the Froude's model law. And what is Froude's number then? And the Froude's number is nothing but the ratio of the square root of the inertia force to the gravity force. So here in the dams, the gravity force is predominant, and obviously we have to take the Froude's model law, which states that the model, the Froude's model for the model and the prototype are the same. So the third one is a very different kind of a situation where I suddenly close the valve of a pipe, right, and such kind of a phenomenon is going to be causing a lot of disturbance in the pipe, and there's going to be a lot of variation of pressure inside the pipe. So what would I do in this kind of a situation? So I will have to use a law called the Euler's model law. What is that Euler's model law states? Correct? The Euler's model law states that the Euler's number for the model is equal to Euler's number for the prototype. So what is that Euler's number? Euler's number is nothing but the square root of the ratio of the inertia force to the pressure force. So there's another situation which is going to be coming in our way, that is going to be just sucking some kind of a juice or whatever it is through a straw, right, is a very simple exercise. Or say an elephant taking water from a pond or whatever, such kind of situations. Or even some people some time ago made a small hula hula regarding Ganapati drinking milk, right, and this is purely due to surface tension effect. And whenever we have this kind of surface tension effect, we can go for another model is called the Weber's model. And the last one, of course, is going to be a very critical thing for the jet planes and other things, and where there is going to be a lot of chaos, and this is possible using a Mach model. Mach model is nothing but Mach number for the model is equal to Mach number for the prototype. So using this, we can arrive at certain situations and conduct a lot of experiments in-house and in our small laboratories, and then overcome the kind of difficulties that we would in real-time analysis will have to face. So thank you very much for this.